We're going to discuss composite functions here, and really this falls under a broader category of operations on functions. Earlier you may have discussed the operations of adding, maybe subtracting, maybe multiplying, maybe dividing, but we're going to talk about composing, and then we use a symbol which is a little or a rather large open dot, as opposed to multiplication, which of course is a solid dot, a little smaller. Now, the idea of these operations is just like with numbers. If we're given a couple of numbers, we can add them, we can subtract them, we can multiply them, sometimes we can divide them depending on what the numbers are. And that's the idea here. We're given a couple of functions, let's say f and g, then from those functions we can create a new function that might be called f plus g, or a new function that might be called f minus g. That is, we can take two functions and we can add them, subtract them, multiply them, divide them, and we can also do this operation called composing them. And the idea, again, given two functions, we can perform these operations and create a brand new third function. And we, rather than calling it by a different name, we just show the operation. So if we're given two functions, in this case we're calling them f and g, the composite function that we denote by f composition g, f with a little circle there you see, it kind of looks like a fog, and sometimes students in fact say fog, but denoted with that operation, the compose operation, we read that as f compose g, and it's defined in this fashion. Now, let me tell you what this fashion is. Remember, this is a brand new function, f compose g. And to define a function, we have to define its rule. So we want to know, and I'm putting it in parentheses so we know it's all together, we want to know what this new function does to some input value of x. And here's what it does. We first put that input value of x into the function g. Okay, we put it into the function g. And once we put it into the function g, a result comes out, and that result's called g of x. And that's what I've written down here. But after we get that result out, we put that result into the function f. Okay, so that's the way we define the composition. It's actually putting input into a function, getting a result out, putting that result into the remaining function. Also, if we had g compose f, now unlike multiplication, composition isn't necessarily commutative. We'll probably get a different result, but here's how we do it. In this case, the input goes into the function f first. And so we get a result out of that called f of x. And we put that resulting f of x into the function g. So that's the way we define those. And of course, we're going to need to look at several examples so that we understand what is going on here. In fact, let's do that right now. Here's an example. Okay, let's say f of x is the function, how about x squared plus 3x? And g of x is the function, how about 2x minus 1? Okay, so a part, we're going to find f compose g. In fact, let's do this. Let's find f compose g of 2. Let's do that. So what this tells us that we need to do is that to find f compose g of 2, we need to put the 2 into the g first, okay? And after we finish doing that, we'll put that result into f. So the first thing we need to do is calculate g of 2. And so calculating g of 2, what do? We take that 2, we look above, g of x is 2 times x minus 1, so g of 2 is 2 times 2 minus 1, which of course is a 3. So that's what g of 2 is right here. And so that 3 value becomes the input into f. And now we simply calculate f of that new input, 3. And of course, that's going to be 3 squared plus 3 times 3. And we recognize that that's what? 9 plus 9, or 18. Now, on the other hand, if we were to find g compose f of 2, then what would happen here is we would, let's come below. I may have run myself out of room here, but in this case, we put the 2 into f first. And once we do that, we get a result, and we put that result into g. So we calculate f of 2 in the first place, and of course that will be 2 squared plus 3 times 2. And I believe that gives us a 10. Yeah, that gives us a 10. So instead of having g of f of 2, we found out that f of 2 is really a 10. So now we're looking at whatever g of 10 is. And to calculate g of 10, we say 2 times 10 minus 1. And of course, that ends up being 19, doesn't it? So you see, we get a different result depending on the order in which we do the composition. Now, the truth is, though, we're usually not interested in finding a composition evaluated at a number. The composition gives us a brand new function. And so we're really interested in finding the rule for that function, if you will. So let's take these same 2 functions and let's find the rule for f compose g. So the rule would be whatever f compose g does to x. That is f of g of x. So that will tell us what our new function really does. Now let's remember, though, because I know it's on the previous page, let's remember that f of x, we were told, is, what were we told? X squared plus 3x. Oops, x squared, pardon me, plus 3x. And g of x is 2x minus 1. So if we're going to find f compose g of x, remember that is the same thing as putting the x into g first, getting that result, and putting that into f. And I would normally read this, as f of g of x. Okay. Now, the g of x, we're told, is 2x minus 1. So we replace the g of x with the 2x minus 1 that it's equal to. Now, 2x minus 1 becomes the input into f. And what does f do to an input? It takes the input, it squares it, and says plus 3 times the input. And so in this case, the input is 2x minus 1. So that's what we're squaring, and that's what we're multiplying with 3. Now over here on the side, when we're calculating 2x minus 1 squared, remember we have to FOIL that. That's 2x minus 1 times 2x minus 1. And when we multiply 2x times 2x, we get 4x squared. And when we multiply 2x times a negative 1, we get negative 2x. And now we'll multiply the negative 1 with 2x and get negative 2x. And finally, a negative 1 with a negative 1, we get plus 1. So the result of squaring 2x minus 1 is a 4x squared minus a 4x plus a 1. So in this first position, we have 4x squared minus a 4x plus a 1. And then we've got plus 3 times 2x minus 1. Well, 3 times 2x, so that's what we're doing right here. times 2x is plus 6x, and 3 times negative 1 is minus 3. And so now we'll simplify this, and you see that we'll have what? A 4x squared, and a minus 4x and a plus 6x is a plus 2x, and a 1 minus 3 is a negative 2. So this is the rule for F compose G. Now, note that earlier we calculated F compose G of 2. And we did that just based on the definition. We didn't have the formula for F compose G. And we calculated. And remember what we got? We got an 18, didn't we? Well, see, we could have done it the way we did, or we could have calculated the rule that we've calculated above, and then use the rule to find F compose G of 2. So what does the rule say? Well, it says we take our input, which is 2, we multiply our input squared by 4. That is, we square our input and multiply by 4, so I'm just looking at the rule here, plus 2 times our input, which is 2, and then just minus 2. And of course, 2 squared is 4, so here we have a 4 times a 4. 2 times 2 is 4, so here we have a 4, and here we have a minus 2. So this is 16 plus 4 minus 2, and you'll notice that we get 18, the same as we got a while ago, but this time we use the rule rather than doing it an item at a time. Now, notice also, let's find G compose F of x this time. So the rule for the new function G compose F. So we go about it in a very similar fashion. First, we have to understand the process, and the process is that we find f of x first, and then we put that result into G. So I read this as G, we read it, remember, G of f of x. But f of x, remember, is x squared minus 3x. So inside these parentheses, we replace f of x with what it's equal to, and that's x squared plus 3x. So now we have an input into G. And the input's x squared plus 3x. What does G do? It says 2 times the input minus a 1. And so our input being x squared plus 3x, we're going to multiply 2 with that input, and then we're going to subtract 1. So the result we'll get here, 2 times x squared is 2x squared, plus 2 times 3x, which is 6x, and then just simply a minus 1. And you notice that's a completely different formula than we had up above. See, remember here is f compose G of x. That's what we have right here. And now G compose f of x is completely different, isn't it? And like we did a while ago, remember earlier we found out, from previously, we found out that if we took G compose f of 2, we would get a 19. And we did that before we had the formula for G compose f. You see here we can use the formula to calculate G compose f of 2. That just means we would replace all of our x's with 2 because 2 is our input. So we'd say 2 times 2 squared plus 6 times 2 minus 1. And of course, 2 times 2 squared, well, that's 2 times 4. And 6 times 2 and minus 1. So that's 8 plus 12 minus 1. And of course, you see that gives us 19 like we got before. Now, you can even use composition. Of course, one thing to recall from this is when we switch the order of the composition, we normally get a different result. Okay, so and that's something to keep in mind. But we can also, just like we can add the same number together, 2 plus 2, we can also compose the same functions together. So let's look on the next page at let's say f compose f. Okay, so we're to find f compose f, which really means we're asked to find the rule for the function. And remember that f of x was given to us as x squared, what was it, plus 3x? Yes, x squared plus 3x. So if we're going to find f compose f, we really need to find the rule for f compose f. That is, what does it do to some value x? And so first, that x will go into the f, and that's really this f, isn't it? And then after we find out what f of x is, the output, we put that into the second f, and that's the f we have there. Well, we work from the inside out. F of x, that's what we're looking at here, is really just x squared plus 3x. So we end up having x squared plus 3x as the input into the function f. And remember what f does. It squares the input and it says 3 times the input. Well, the input here is x squared plus 3x, and so that's what goes in each of these positions. That's each of those positions we see there. Whatever, that's where the input goes. Well, we have a little bit of work to do here, of course, because we need to calculate what x squared plus 3x being squared is. And that's just x squared plus 3x times x squared plus 3x. It really crowded things up a bit. To do this multiplication, we have to multiply the x squared and the x squared, don't we? So that gives us x to the 4th. Then we have to multiply the x squared with the 3x, and that will give us 3x cubed. Then we turn around and multiply the 3x with the x squared here, and that ends up giving us another 3x cubed. And then finally the 3x times the 3x, which will be plus 9x squared. So the result of squaring that input gives us an x to the 4th plus a 6x cubed plus a 9x squared. So that's what goes in this position, x to the 4th plus 6x cubed plus 9x squared. Now we need to multiply the 3 with the x squared plus 3x, and you see that gives us a 3x squared plus a 9x. And then we see that we can simplify further by combining the x squared terms. The 9x squared and the 3x squared added together is certainly 12x squared. So the result of composing f with itself is this new function, or that's the new rule for the new function f compose f. And likewise, we can calculate g compose g, but I think we'll save that as an exercise. Okay, let's change the functions and just see that now that we hopefully understand the process, the real effort will end up being how we deal with the algebra. And knowing what to do is one thing. Accomplishing the algebra to simplify ends up sometimes being another. Okay, here we're given two new functions. F of x is the fraction 2x plus 1 divided by x minus 2, as you can read. And g of x is the fraction 3 over x. And we're asked to find both f compose g and g compose f. So let's start out with f compose g. Now remember, when we're finding f compose g, it's really asking us for what's the rule for this new function. That is, how does it act on an input x? And so we set up by rewriting this in a form that we can work with, f of g of x. And as we have before, we start on the inside. G of x above is 3 divided by x. So we simply replace g of x with 3 divided by x. Now, what we need to do next then, of course, is use that input 3 divided by x into the function f. That's that new input into the function f. Well, what does f do? It takes an input and it multiplies it by 2, creates a fraction, where the numerator of the fraction is 2 times the input plus 1. And the denominator of the fraction is the input minus 2. So in this case, the input is a 3 over x. That's what goes in both of those positions. Well, as we begin to look at this result, when we say 2 times 3 over x, we get 6 over x. And then, of course, subtract 1. And the denominator is 3 over x minus 2. So we've created f composed g of x. But the problem now that we're dealing with is the result is not in simplified form. This is a complex fraction that needs to be simplified into a simple fraction, meaning no fractions within the fraction. Now, if you recall, one of the ways that we've dealt with this thing in this type of situation in the past is we want to make those fractions disappear. Now, that is, to make the fraction 6 over x disappear, we want to cancel that denominator. We'd have to multiply that fraction by an x. But we can't just multiply a single fraction by an x. What we could do is we could multiply the whole numerator by x. But if we do that, we'd have to multiply the whole denominator by x. Now, we're fortunate here that when we do this, both of those fractions are going to reduce, aren't they? Because what we're going to do is we're going to distribute. We're going to have this. Let me write it out this way. We're going to have 6 over x minus 1 times an x on top, and we're going to have 3 over x minus 2 times an x on bottom. And so now we're going to distribute that x. We're going to say x times 6 over x. See, we're going to have 6 over x times an x minus a 1 times an x. Normally, I'm not going to go through this much detail, but it may have been a while since you've done something like this. Now, on bottom, we've got to distribute the x. So we'll have the 3 over x fraction multiplied with x minus the 2 multiplied with an x. That x is multiplying both pieces. And, of course, well, sorry for that little interruption there. As we're multiplying the fraction 6 over x with x, we just get 6. And then minus 1 times x, which is, of course, just x. In the denominator, we have the fraction 3 over x times x. Of course, the x's will cancel again, so we end up with just 3. And then minus 2 times x, which, of course, is 2x. So we had to remember a little algebra to simplify this, but this is the rule for f composed g of x. On the next page, we'll do g composed f of x. Okay, so to find g composed f of x, we set it up again. We're going to calculate g of f of x. And as before, we start on the inside. That is, f of x, we replace with what it's equal to. And it's equal to the fraction 2x plus 1 divided by x minus 2. So that fraction ends up being the input into g. Now, what does g do with input? Well, it creates a fraction. G creates a fraction that is 3 over the input. And this time the input is the fraction 2x plus 1 over x minus 2. So now we have to remember how to simplify that. Now we're dividing by a fraction. And so when you divide by a fraction, it's the same as multiplying with the reciprocal of the fraction. And the reciprocal of the fraction 2x plus 1 over x minus 2 is x minus 2 over 2x plus 1. So we're multiplying 3 with that fraction, and of course that means we're going to multiply 3 with the numerator x minus 2. Notice I didn't do this. I hope that we recognize that 3 is just going to multiply the numerator, and the denominator is not being multiplied or being multiplied by 1. So when we simplify here, the numerator ends up being 3x minus 6, and the denominator 2x plus 1. So that's the composition G compose F, and that's the rule for it. Now, what I want to do next, and you may have homework that requires this, and may have homework that your homework may not require it, but there is an issue about finding domains, and so when we're talking about compositions of functions, it may not be so simple as we might first think that it is. So here's what I want to do. Let me tell you about domains of compositions. And we'll do that on the next page. When we're dealing with the domain of a function f composed g, remember how things work. If we're looking at f composed g and we want to know how we calculate that, well, we calculate it by first putting the x value into g. And so that's what's meant right here is the domain of f composed g is the number values x that are in the domain of g, because we put the x's into g first. But then after we put those x's into g, we get a new output from g. And that output has to go into f. And so that's what's meant here. We've got to make sure the output that we get when we put x in is something that we can use in f. That is, it's in the domain of f. G of x has got to be in the domain of f. So let's just let's look at an example like this. Let's just assume, before we do anything for real here, let's suppose that f of x is 1 over x squared, and g of x is equal to x cubed. Just do something like that. No, that's not what I'm trying to do. I chose a bad example. Let me just start from scratch. Let's find the domain of f composed g and of g composed f, given that f of x is, let's say, the fraction 6 over x minus 3. And g of x is simply the fraction 1 over x. Now, what I'm going to do first here, because I'm trying to make a point of something, so what I want to do first is just to calculate f composed g of x, okay? So let's calculate that first. And so that's f of g of x. And so that means we put g of x, we replace g of x with 1 over x. And then we put that 1 over x input into the function f. So that's 6 divided by our input, which is 1 over x, not x, and then minus 3. And then we're going to simplify that by multiplying the numerator and the denominator both by x. So the numerator becomes 6 times x, and the denominator becomes x times 1 over x minus 3 times x. So we end up with 1 minus 3x. Now, if we looked at this function, okay, if we looked at this function and we decided, okay, what's the domain using that formula only? What's the domain of that? Well, what we would worry about is 1 minus 3x. We can't allow it to be 0. And so we would find out what causes that to be 0, and it's x equal 1/3. And so we might think, well, we can use any x but 1/3. But that's not true, okay? That's not true. That's not. We may not be able to use 1/3, but we have to note, not by the formula, okay? We don't use the formula to make the decision. We don't use the formula. Okay? We here's what I mean. That if we calculated f of g of 0, well, what would that require us to do? That would require us to calculate f of g of 0, that is, f composed g of 0. And when we went to calculate g of 0, we would get 1 over 0, and so we have a problem. That's undefined. And so we can't allow x to be 0, or we can't even do the calculation. Now, the other thing that we have to be worried about here, and this one is going to show up all right, we can't use an x that causes g of x to be 3. Now, see, and the problem is g of x is going to go into the function f. So when is g of x actually equal to 3? Well, that would be when 1 over x is equal to 3, and that would be when x is actually equal to 1/3. So here's what would happen. If we put 1/3 into this function f composed g, the first thing we'd have to do is calculate g of 1/3. Okay? Well, g of 1/3 is 1 over x, x being 1/3, it's 1 over 1/3, and that's actually 3. And so now we would be calculating f of 3, and the problem with that is calculating f of 3, that would be 6 over f of what? 6 over x minus 3, or 6 over 3 minus 3, which of course is 6 over 0, so that's a problem. So there's two different values of x. X can't be 0, and x can't be 1/3. Those are the two different values. Okay, so we have to have an x that g of x makes sense, and we have to have an x that g of x can be used in f. In this case, g of x can't be the value 3. So for our domain of f composed g here, we didn't look at this bottom line, although that gave us part of it. What we had to do is look at the different components. And so here the domain is the set of all x's such that x is not equal to 0 and x is not equal to 1/3. It can be equal to anything else. And the formula only gave us half of that answer, didn't it? Well, let's do the domain of G compose F, and then we'll call it a day here. Okay, the same two functions, but we want to know now the domain of G compose F. So the idea, though, is we have to use x values that f of x makes sense. See, f of x must be defined. Okay, and so that means x can't be 3, otherwise we'd have 6 over 0 be defined. Whoops, I got those backwards, didn't I? So that means x cannot be equal to 3. Otherwise, we'd have 6 over 0. Okay, now here's the next thing. F of x, okay, f of x must be in the domain, because after all, what are we going to do? We're going to find g of f of x. So we have to use x's where f of x makes sense, and then we have to use x's where f of x will go into g, that f of x is in the domain of g. So f of x must be in the domain of g of x, which is 1 over x. In other words, f of x cannot be 0. Otherwise, it wouldn't make sense when we put it into g over here. Well, then what causes f of x to be 0? Well, in this case, you know, since f of x is 6 over x minus 3, is there any value of x that causes 6 over x minus 3 to be 0? And no x's will cause this. No x's will allow this, will cause that to happen. And how do I know that? Well, the only way a fraction can have the value 0 is if it's going to create a 0 numerator. You know, a fraction's not 0 unless the numerator is 0. And since the numerator here is 6, no matter what x is, there's no way that fraction, no matter what we put in for x, we're going to get 6 over some number, and that won't be 0. So in this case, there's only one bad value, okay? And so the domain of, here we're talking about G compose F. The domain of G compose F is the set of all x's such that x is not equal to 3. And so we may have missed that altogether if we would have looked at G compose F. If we would have looked at the rule. See, if we would have calculated G compose F, actually gone through and calculated that, we would end up with, and you can verify this, I'm not going to go through the process, but if you did go through the process, if you go through the process, that's the result you're going to get. And so when we look at that, we think, oh, we can use any x value. See, we can use any x value because using a 3 value is okay because that would just give us 0 over 6, which is 0, if we looked at the formula. But we can't use the formula to decide the domain when we're looking at a composition because we have to have numbers that make sense going into F. And so, and the 3 doesn't make sense going into F. It would be undefined from the very beginning. It's a strange thing to get a hold of, and it takes a little bit of practice to be able to determine these domains of compositions. Mostly I'm interested in you being able to calculate, go through the process of calculating a composition and remembering that G compose F and F compose G normally are different results. Okay, well, that's all we're going to talk about compositions today. Good luck on your homework.